Okay, today we'll go into polar form. We already done Cartesian form. Cartesian means x, y, and z. Polar form, we will deal with pi and also some angle. Okay, so let's say we have a complex number, x plus jy. So if you draw on the Argand diagram, so you should look something like this. So your x means real component, j is an imaginary component. So x and jy like this. So when you draw on the Argand diagram, this is your vector from origin. R is your complex number. Yeah. Right. So how you find the distance of OZ, which is R, is using your trigonometry equation, right? So from trigonometry, your x, how you find your x means you use the r cos theta. How you find this jy is equal to r sine theta, the y magnitude. No? J, it just means that in imaginary axis. Okay. Any question on x and y? No. Okay. So to find your z, if you write in the r form, your z equal to x plus jy, you can write in r form, which is a magnitude form, equal to r cos theta plus j r sine theta. Yeah. So we have covered the front part in the previous chapter, which is we see x and y. But now, if sometimes the question we only know the magnitude, and we know the direction, which is the angle, then we can write our complex number in r cos something, r sine something. Yeah. Right. So when you bracket them, you pull out the r, you factor out the r. Your r bracket cos theta plus j sine theta. This one, if you write in cos theta and sine theta, or you see the theta, this form that I highlight in yellow color, it means polar form. If the question asks you answer your question in polar form, means you need to split your magnitude into theta form, or sine theta or cos theta form. Yeah. So z equal to x plus jy, this is in Cartesian form. But if the question asks you to transform your complex number in polar form, you need to draw the Argand diagram. From Argand diagram, transform into the magnitude. Yeah. So how to find the R? R is called modulus, or in the previous mathematics, you see the double goalpost there, right? It's called modulus, or in short, we write MOD, modulus Z. So same with Pythagoras theorem, right? If you see this triangular consists of ABC, how to find your hypotenuse? This section square equal to this section square plus this section square. So we use the same. If we refer to this Argand diagram, how do you find R? Is your R square equal to X square plus Y square. Then you move your square to the another side, which means square becomes square root. So this is how you find your modulus. Yeah, this just recall your hypotenuse, Pythagoras theorem. Okay, so from here, how you find your x? If you're given coordinate, you should be able to know how to find the length, like what you see in your static just now. Okay. So, and then the angle in the complex number, we call it argument, or amplitude. So we write them write as argz with argument. So argument z equal to theta. How to find theta? You can use sine, you can use cos, depending on the information you have. So in this case, we use the most common one, which is tangent, which is opposite divided by the side, or the y divided by the x. Okay, but you have to, why there's a negative one there? Because tangent is over on the left. You transform left to right, you inverse the tan. Okay, so you should know how to use a calculator to press tangent inverse. Okay. So these are some side note that you already learned in the previous fundamental mathematics. Just to recall how to, what is Pythagoras theorem, what is trigonometry ratio, and this. So this is just some information. Sometimes you need to draw out to visualize what actually the complex number, how it look like, and so on. Okay. Okay. So just an exercise, if you understand. So we have a quick exercise. Determine the modulus and argument for this complex number z equal to 2 plus j3, and express the z in polar form. So in this case, you draw the Argand diagram first, right? So this is real number, this is imaginary number. So you have your x and y direction. So you just draw it just to visualize, right? So it's in first quadrant. So just recap. This is first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. So your first answer in your, if this one come out in the test, the first that we expect is the Argand diagram. You should draw the imaginary axis and real axis, and then put in the real number 2. You should mark 2 on your axis. In the test, usually we don't go and measure the whether scalable or not. To us, the scalable is not an issue. We want to see you mark 2 on the axis, mark 3 on the imaginary axis. That is more important. Okay. So in this module, we don't really go and measure whether got scalable or not. No, because you only want to see the important point there. Okay. Then once you have the 2 and 3, connect the origin 0 to the corner of the box there. So remember to use your ruler to draw the straight line, vertical line, and horizontal line. Then you connect the O to the corner of the box and label as R and label the theta. So today, what you learn something new with is the R and theta. Then from here, you convert into sine and cos. Okay, convert into sine and cos. So modulus is actually your x squared plus y squared. Okay, modulus, you write modulus, then double goalpost, z, modulus, equal to R, equal to your x squared plus y squared equal to R. This is the Pythagoras theorem. So 4 plus 9, 4 plus 9, 13. So in the test, you can put in, sorry, it should be square root 13. Typo error. Should be square root 13, not 13. Should be square root 13. Equal to 3.606. In this module, use minimum 3 decimal place. Okay. Huh? No, this is so far we haven't have any unit yet. Later in the practical question, then you'll see unit. Here we only look at how we find the real component and imaginary component. Argument is the angle. So for this module, we use tangent equation. So equal to tan y divided by x. Your y is 3, x is 2. You press your calculator, you'll get 56.31 degree. And in other, as you go deeper later on, in your core module, especially on the orientation of orbit or something, especially on the Earth orbit, something outside space, we will convert into minute. Okay, 1 degree equal to 60 minutes. So this one 0.31 multiply 60, you get 19 point something lah. You get the full number, and the comma is minute comma. Huh? Okay. So this is just a new introduction on the presentation of data. For your test, it's enough you stay at degree, but we put in the minute just to introduce you. You might see this one in other modules, especially in your senior years module. Okay. So polar form, your answer, you written 2 plus J3 equal, you write in this form 3.603, and then there's a angle there, angle 56.31 degree. Okay, so this is your final answer, the one in the yellow box. So you need to tell me, you write 2 plus J3 equal 6.606, and then angle 56.31 degree. Okay. So if you understand this one, you should be able to do ABCD. This one, your homework. So I assume you already understand the theory part. Okay, all the answer for ABCD is inside my slides. What I need to highlight is the positive and negative sign. This is a careless mistake error. Okay, so this will be the answer expected in the Argand diagram. Okay, modulus, especially the angle. I want to highlight the angle. So first quadrant, no issue. What happens if you go to second quadrant? You see, the angle is different already. For second one, it is in second quadrant. You are calculating the alpha, right? The alpha is 53.13, but the answer is not 51.13. The argument for second vector or second complex number is not 53.13. It is measured from real axis. It is from here to here. From here to here. So how to find here to here? Take 180 minus alpha. So this is the wrong argument. So it's only find the alpha. So don't write argument alpha. Just remove argument. You can write alpha equal to tangent that one. Okay. So this is just a highlight. Argument is from the real axis, which is anti-clockwise. So argument, the answer is 126.87 degree. This will be the careless mistake in test or final exam. You will stop at alpha. Just take note lah. Don't make these mistakes. Right. So let's see. So the answer will be like this. Minus 3 plus J4 equal to 5, angle 126.83 degree. If you don't write the color box, you will have lose at least 1 mark or 2 marks if you don't write this one, if you don't write the yellow color. Because up to argument, this is the step point. You do not conclude your answer. You need to conclude the answer. Okay, let's see the quadrant 3. Quadrant 3, let's say you know how to find the modulus, you know how to find the another alpha here. Right? You know that this is 53.13. So what is the argument? 180 plus this one. So the argument will be 233.13. Okay. Right? So let's see. So another presentation, you can say, can I write negative or not? Can, but we always like positive value. Yeah. So for the test, it's good you always give me positive number, but in sometimes, especially in other module, sometimes in a question we don't give you direct answer, we'll give you negative value. Then you need to know what actually the question trying to ask you. Yeah. So there are two answers for this one. For quadrant 3, either you give positive 233 degree or you give negative 126 degree. There are two answers. Negative means you go clockwise, but for complex number, usually we are having anti-clockwise from real axis. Yeah. What happened to quadrant 4? Quadrant 4 also the same, but you need to give in the correct way. If, like for example, quadrant 4, the answer expected will be negative 53 or 270 plus something here. Because sometimes if you give larger number, you need to add like this. Sometimes shortcut is negative. So in test, you can give two answers, one is positive, one is negative. Yeah. So this is from Cartesian to polar. The question might reverse. What happens if the question gives you polar and you need you to convert into Cartesian form? So the step will be the same. You just reverse it. So first you use the Argand diagram. 430 degree means in the first diagram, first quadrant. This, you draw something like this. Then you can find the x and y, right? The x will be 4 cos 30, y will be 4 sin 30. Okay. So you have your x and y already right in the a plus b form. So this is the expected answer. You write 4 angle 30 equal 3 point something plus j2. And this is the way you reverse it from polar into Cartesian. Yeah. So Argand diagram is very important in chapter 3. Yeah. So far we still on the Cartesian, trigonometry, Pythagoras. Okay. So the rest you read. Only I need to highlight is the angle. Always careless mistake from the student is angle. So this one is negative 145. You count anti-clockwise, negative 145. So sometimes you see this one, you panic already. What? Suddenly you blank, you don't know how to do. Okay, so this is just a reminder. Just a reminder. Okay. And try to familiar with your calculator on the polar and rectangular function. This one you go and see different calculator, different way of doing it. Okay, then we go into multiplication and division. It will be the same as Cartesian that you learned. So let's say we have two polar form complex number. Z1 equal to R angle 1. Z2 equal to R2 angle 2. So these are the short note for a few pages of textbook. I just summarize into two yellow color equation. If you multiply Z1 and Z2, what you do, you multiply the real number, and the angle will be, you add them together if it's multiplication. Okay. If division, you minus the angle and you divide the real number. These two yellow color formula is important. Every time that you see the question asks you to multiply or division, this will be the starting point. You need to write the general equation. For entry mathematics, always write the general equation, what you're trying to do. We saw substituting the number. Okay, so this will be have the marks. You always, when you write the equation, you will have marks. Okay, questions. What happens if you have 3 complex number? We have Z1, Z2, Z3, what happened? You do Z1, Z2 first, then you do Z3. Of course, you can, because you got divide. If you divide, then how? Okay. So, and sometimes in other module, core module, we'll use pi to represent the angle in a pi form, right? So 1 pi is 180 degree, half pi is 90 degree, and so on. Okay. Pi means in radian already. Okay. So let's see how we determine. So if you take Z1 A, Z1 8, 25 degree, multiply 4 by 60. So just by mental calculation, you take, if it's multiply means you multiply the real and then you add the angle. So 8 multiply 4, 32, angle will be 85 degree. If you, and then this one is minus, you see the minus, yeah. So this one is 3 times. So B you know lah. So B will be straight away multiply, just to multiply should be no issue, but division need to careful a bit. Okay. Yeah, the concept is these 2 general equation. Multiply you add, divide you minus. That is on the angle part, angle part. But the real number you just do like a normal real number. Okay, so something like this, you will see something like this. How you do? So here you just divide, but only the angle is minus. And this one also same. You do the top one, then only you do the divide. Okay, the first one should be no issue. 16 by 2 is 8. 75 minus 15 is 60. Okay, this step is important. You need to write in your test. So this one also same. So this one a bit faster. Okay, just do the real number and then do the angle. Okay, the bracket multiply is plus, divide is minus. So usually the careless mistakes are like this one is there's a careless mistake here. What is the mistake? Negative sign is missing. So it should be negative sign in front there. So if this one is in the test, it should be a wrong answer. Okay, in the test, if the step is wrong, you give me correct answer, also wrong answer. I will mark from the top to bottom. If your step wrong already, I won't mark further. Okay. Okay. So addition, if your polar form is not possible directly, so you need to convert into Cartesian form first, especially this one. So we go back to the just now is addition multiplication, but addition is polar form a bit complex. Polar form like this plus is not direct. Because you got angle, then you have x direction and y direction. So it's the difference. So let's see how we do this one. So evaluate polar form, you have a plus 3 complex number in polar form. So how we do? We need to convert each one of the polar into Cartesian. So 230 means 2, you need to multiply cos 30 and sin 30. If you don't understand this one, you just draw the Argand diagram. Okay. So you can either maintain this this one, or you can straight away do this one. Okay. Then you do the same for second one and third one. So second one, 5 angle negative 45, you get 3.5 minus J 3.5. For 120 degree, at the end you will get minus 2 and J 3.4. Now once you have this number, then you can add and minus. Okay. Once you get real number, add together or follow the sign, right? Especially this one. Careless mistakes is that sometimes, like for example, this one, for 120 degree is negative 2. But you forget that the original question, there's a negative 4 there. So it's a positive. But this one become negative. So you should start to use the bracket form to help you to avoid mistakes. Okay, just a reminder. Use the bracket to eliminate the mistakes. Okay, so this is the answer for that one. Okay, then sometimes when you add this one, the question will ask you evaluate. Of course, this kind of question is not complete. In the test, we will be very specific what you need to do. Okay, so sometimes the question asks you to identify which quadrant, and then asks you to find the modulus and also argument. Okay. So he asks you evaluate in polar form. The final answer should be in polar form. Meaning, if a plus minus polar form, you convert into Cartesian, do the Cartesian step, convert back to polar form. Yeah. Right. Okay, so this one is your homework. Go home and do. Don't need to pass it to me. Just go home do. And there is an answer behind the thing. So there are more than 10 questions here. So just go home and do. Okay, then we start to maybe 10 more minutes. Then we dismiss the class. Right? So application of complex number. Where do we use the complex number? In electrical and also vector analysis that you see in the statics. Right? So trigonometry, just recall back what happened if you ask to draw a function y equal to sine theta with this sinusoidal form. Because electrical current is either in sine and cos. AC power especially. DC is one straight line, direct current. So it's actually rotating anti-clockwise. So you follow So just this is between the sine and cos. The differences is half pi. Okay, half pi. So it depends on the angle you go and the angle is from the real axis. Anti-clockwise angle is anti-clockwise. Okay. Okay. And also call back what is tangent graph. Tangent graph looks something like this. There's an infinity at the 90 degree. Okay, so just bring back a little bit or help you in the circuit design a bit, right? So they are scenario in a complex number. So in electric current, if they are in phase means the angle is actually match each other, synchronized. Like for example, the angle point actually the same. 0, pi, 2 pi, 3 pi. They meet the red color and the blue color, they close at the same phase. Right? Although the amplitude is different, but the angle is same. Okay, so it's some usually you look like this. So you have a resistor, and then you have a voltmeter. The current will go something like this. Then you use this formula. IT equal to Vmax divided by R sine Wt. W is a rotational parameter. Okay, so but this is just introduction, right? So what happens if the question in the application of complex number is say the current lag behind the voltage by a phase of 90 degree. 90 degree means half pi. So you'll see the red color and the blue color. Red color is the voltage, and the I is the current. So you say current lags behind. It means you find the means in this case V start first. Before V start, the current haven't start. It's still at the negative component. If you pull this to here, you will see that it is a half pi there. Okay, this point to this point is pi, half pi. Okay, 1 pi, 2 pi, 3 pi. Huh? Yeah. So the blue color, if it lag behind, means it shift the blue color half pi. If the current leads, the I leads means you shift the I to the back a bit. How you know is lead or lag? If current lag means it's in a negative, imaginary will be start with negative. If it's lead, it will have a positive imaginary component. Voltage always our reference point. Voltage doesn't change. Voltage always same. Okay. So in mathematics calculation, how you present whether it's lag or lead? When it's lag means negative. Something negative, pi divided by 2. If it's lead, you have plus 90 degree, pi divided by 2. Okay, the formula will be given in the test if this one come out. Okay, so once it's given, yeah, then you choose which one is the scenario. Okay, this is just a revision. If it's we look at the diagram first. Diagram, you have degree 0 and it's anti-clockwise. So if you have 90 degree rotation, means you have a positive J here. J is positive because it's shifting anti-clockwise. So let's say the magnitude is 1. So when it shift up to 90 degree, you'll meet 1J there, positive 1J. So positive 1J actually is square root of -1. Then when it shift to 180, it's 2J already. 2J is -1. Sorry, J squared, not 2J, J squared. And you rotate further 230 degree is J cube. J cube is -J. Okay. And 360 is 1. Yeah. This is on the imaginary dimension. Real number, don't confuse with real number. It's on the J part, the behind one. Yeah. So the rest you read. So Fraser, some question, application question, they purposely ask you the electric diagram. So this will be the Fraser diagram. It looks something like this. So with the L, R, I quite standard, right? So this is the VR, this is a VL. So this is the diagram in the first quadrant. If you see this one as quadrant, this is the first quadrant. So if in the first quadrant, VL will lead I by 90 degrees. This is VR and this is the axis will be 1I here. So V is this one. V is this one. If you split the big V, you have Vx and Vy. But in this case, your X is R, your Y is L. So if you turn your V modulus into X direction, the length from O to VR is only this length, right? And your I is a bit longer. So in this case, your you can say in this case VL lead I by 90 degrees. So you can write like this. Your V in the complex number form will be VR plus JVL. VL is an imaginary component in the electronic diagram. Okay. And the Ohm's law, V equal to IR. And VL equal to IX or capacitance. So induction. So inductance is equal to 2 pi FL ohms. Right? But basically, you can just assume XL equal to R. It's similar like R. Right? So sometimes Z is impedance. So you write Z in the Z form. You move your I to the left-hand side. V equal to I equal to Z. And V, capital V in the complex format, V equal to VR plus JVL divided by I. And you can split, substitute VR equal to IR, VL equal to IXL. We can write in this form, when you divide the real number, IR divided by I, you get IR divided by I, you get R. IXL divided by I, you get XL. You remove the I. Yeah. So this is a diagram, Fraser diagram, which is the V leading I. This diagram is V leading R. At the moment, you just accept although it's not electrical class. I just bring back this one. If you see capacitor, it will go to the fourth quadrant. The V will go to fourth quadrant. And this is the phi, or you can say angle. VR always in the real axis. And VC just now is L. Now, if you see the capacitor will go to negative side. Meaning, if you see L in the diagram, you use Z equal to R plus the imaginary component, R plus JXL. If you see capacitor, you use minus. You use minus. Okay, let's see how we apply this one with the complex number. So this one actually already application in the electric circuit already. So that's why I spent some time to explain what is C and L. Then we go into application. Right? So we want to determine the resistance. Series inductance resistance is R. Series induction is L. Or can be capacitance with is C. It can be L or C. Right? It depends. So if it's induction, it is L. L is positive. If it's capacitance, it's minus. Okay, then you're given the frequency of 50 Hertz. Why this question got mentioned 50 Hertz? Because there's one hidden equation here. Your XL equal to 2 pi FL here. Okay, just observe the application. So because it is this one is plus, this one is plus impedance. Z equal to 4 plus J 7 ohm. You want to determine the resistance and series induction. So 4 is your resistance. Okay. 4 is resistance. The answer is resistance equal to 4 ohms. Your reactance is 7, is imaginary number. So you learn this term in the electric circuit design. But for this module, what is important is you're able to identify which one is the real component, which one is the imaginary component. And then if in application, what does it mean real? What does it mean imaginary? Okay. In circuit design, resistance is always real. And outside resistance, other than resistance, is an imaginary component. Okay. So if you see positive, it is under inductance. We have inductance and capacitance. If you see a complex number with positive, it is under inductance circuit design. That means the inside circuit got L symbol. Okay. So XL equal to 7. Then recall this circuit design formula. XL equal to 2 pi frequency L. You want to find inductance, which is your L. So 2 pi FL equal to 7. You rearrange the equation. L equal to XL divided by 2 pi F, which is from here. Then substitute the value, you get the answer in H. M means milli. M is milli. Okay. So this is application on the complex number. Okay. Okay, what is important is, again, you can able to identify the real part and the imaginary part. In circuit design, there are only two types of complex number. Either is induction or capacitance. Okay. Positive one is induction, negative one is capacitance. Okay. You see here, B, B, Z equal to minus 7. So the real part is 0. If you don't see anything in front, it's 0. 0 means what? Your resistance is 0. There's no resistor there. Okay. So then the rest you apply back. If it's negative, is a capacitance. Capacitance, the formula is not the 2 pi FC, but it's 1 over 2 pi FC. There are two sets of equations. If it's fall under inductance, you use 2 pi FC. If it fall under capacitance, you use 1 over 2 pi FC for the XL. XC, sorry, not XL. This is just application. So let you see where does the complex number used in the daily life. Okay. This one you go home read. Okay, so before we forward, 15 angle 60 degree. Are you able to tell it is capacitance or induction? Cannot. You need to change into Cartesian first. Then only you can see this form, whether positive or negative. Okay, this one you go home read. This one also same. You are given voltage, hertz, impedance is given like this. So negative one is capacitance. Yeah, this one you go home read. If you understand the previous one, then should be no issue. Yeah. So you go home read. If you have question, you come and ask me. Okay. I don't want to load you with a lots of question, lots of info. This one, you also go home and read. This one is a combination of circuit design, right? Meaning you have parallel here. Parallel, you need to 1 over this, 1 over this, 1 over this, plus, and so on. Okay. Go home read. Answer is there. So you need to recall circuit design, you need to use this equation and so on. Okay. Application of what we learned, conjugate here is applying the conjugate. When we have 1 over factorize the fractional of complex number. This you need to recall. When you have 1 over complex number, you need to eliminate the factorial format by using conjugate. This is where you apply the conjugate concept. Okay, go home and look at this example. This is statics. After this, we stop the class, and then see you guys tomorrow. Okay, so this example, it asks you to determine the magnitude and direction of the resultant of 3 coplanar force. It's what your case you need to solve in Dr. Zubaida class. Force A, you have 10 Newton acting at 45 degree. Horizontal axis. B, 120 degree positive horizontal. C, 50 Newton acting at 210 from positive horizontal axis. You have 3 forces. You need to determine the resultant force of 3 forces. Okay, how you do? You need to draw something like this. Draw the forces first. From the horizontal, of course, this one is 2-dimensional. First one, 10 Newton, you draw 10 Newton. And then angle is 45 degree from real axis. This is a polar, can say polar presentation, but there's no one name for the diagram, right? So then you draw the second one, 8 Newton. You draw the third one for 15 Newton with the angle, right? Okay, once you have this diagram, so you can write in the polar form, FA equal to 10, 45. Do the same for B, do the same for C. Okay. Then resultant force is a plus additional. So you have real number and imaginary number. Real number, 8, 10 plus 8 plus 15. Angle, because it's 8, so it is a additional. Okay. So polar form into Cartesian form. Polar form into Cartesian form. Because this is addition, so addition cannot add, polar form cannot. Only can do multiplication and division. Polar form cannot do addition and minus. This need to be careful a bit. This part. Usually careless mistake happen here. You will go and add the thing up. Okay, once you will get in this form, real and imaginary. From here, positive must from real axis. Yeah, from here, anti-clockwise. For complex number. Okay, then find magnitude and find direction. With this, magnitude resultant is 11, angle is 146.77. 146 or 146 is yeah. So this one is why is in second quadrant? You know why this one say is in second quadrant? Real number, imaginary number. Real number negative. So this is positive, this is negative. Minus about 10. So minus 9 is here. Angle 146. This is 146. Magnitude is 11. 11.86. Yeah? Because you draw the okay, this is your homework. Go home and see whether you're able to do. There are 11 question, not 11, 13 question. Huh? So 13 question. So all these are actually equivalent to 1 hour work. 1 hour work. I mean, okay. Okay, next class we go into this de Moivre theorem. Tomorrow we have class. Okay. Ni print